everybody. So we are going to start a new chapter that is sets of class 11, and we'll be starting sets today. So sets is, I hope this theory was given by George Barton, and the word, if I say sets, it is actually the collection of objects. The collection of objects of some particular kind. So for example, if I say um, so collection of objects does not mean just the objects. It can have anything, names or sports, the names of the sports, the names of the book, or the names of the city. So you can have any collection of object or element or something like that. You can say. So if I say that this is the collection of the names of these sports, so I will say that it's a kind of a set, right? Because what are these names? These are the names of sports. So sports is a particular thing which is related, or these three are related to that thing only. The sports. These are the names of the sports. So we say that this is the collection of objects of a particular time. And what is that time? This is talking about the sports because they all belong to some of the other sports. Now set is actually we don't write this set in such a way because we have certain format in which we have to write this set so that it when it's written there is nothing else to be told that yes it is a particular set. What I mean to say that if I want to write a set, if I want to write a set, so what I'll write I'll just give the name to a set in capital letter, capital A, capital B, anything you can have. So let's say the name of the set I'm presuming it or I'm taking it as capital A. Alright, now let's shift it. So let the name of the set is capital A. We have to equal to sign whatever objects we are going to take. We are going to take or we are going to write them in the curly braces, inside the curly braces. So here, if I want to say that, let's say these are the objects, or you can say these are the elements, elements of the set. Let's take one more. So here, just by looking at this thing, we can see that the photo that you will see here, it is representing a set, which is the name of the set is A, and the objects of the set A are 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 is actually the collection of natural numbers which are less than 6. Can we say like that? Yes. So here the set A is a collection of natural numbers whose value is less than 6. So this is also is a set. Now from above we conclude that the set is actually it is a collection of well-defined objects. Well-defined means if I say to you that if I ask you or if I say this top collection of top 10 most intelligent people in the world. So here, for some particular person, the list of those 10 people might be different because the perception of intelligence is actually subjective. It basically differs from person to person because for a class 1 child, I will be the intelligent person. For a PhD student, or you can say a PhD who is doing a PhD, for that person, I will not be that intelligent. So here we cannot define that intelligence in a particular terms. it varies from person to person. So for somebody, the top 10 intelligent people may be different as compared to uh, the as compared to the perception of other student or other person. So here, the top 10 most intelligent people in the world is actually not a set because the objects are not well defined. Well defined means for certainty, for 100% surety, you can say that those are the members of that set. But here, it is not 100% accurate or 100% surety. We cannot say with that surety that these 10 people are the most intelligent people in the world. So therefore, that will not be offset. I hope you got the point. Now, if I say, is collection of the most renowned mathematician of the world uh, is a set, so you will say no, because for some people, the renowned mathematician may be different as compared to some other people. Somebody must be might be thinking Dr. This Ramanujan, the great mathematician. Some might be thinking the Aryabhat was the greatest mathematician. So the collection of the most renowned mathematician in the world or of the world is actually not a set. So I hope you have understood the well-defined term for the set. Well-defined. This should be very much clear to you all by now. So, in the last, you can say that a set is actually a collection of well defined objects. So, this is the definition. A set is a collection of well defined objects. So, here points to be noted, what are they? The members of the set should have the same nature. For example, if this is the set. So here, this is a set, and it has the numbers as 1, 2, 3, 4. So their nature has to be same. What I mean to say by referring this nature, here all these numbers are actually natural numbers. So the nature of these numbers is what is that? That they are natural numbers. So here, the first thing that you should note is the numbers of this set of a set should have same nature. Is that clear? I hope it is very much clear. Now the second point is that, as I have told you earlier, the name of this set is denoted by capital letter. Capital letter. The name of this set is denoted by capital letter, and it is up to you what capital letter you want to take. You want to write it. The third is the members of the set. If I'm referring or if I'm taking the alphabets of English language, the members of that set should have small case English alphabet. What I mean to say by small letters, they should be represented by small letters. These three basic points should be clear. The nature of the members of the set should be same. The name of this set should be denoted by a capital letter of English alphabet, English language. And the third thing is the members of the set should be small in, or they should be small letters of English alphabet. So here this is a set whose name is denoted by capital letter, whose members are small abc, and they are enclosed in the curly braces. So here this is the name of the set. These are the members or elements of the set. You can say members also, or you can say objects also of set A. And they are enclosed in the curly braces. Now, if I say that this is the particular format in which you have tried to set, okay, if you write this much, then it will be understood that it is a set. The name of the set is A, and the elements of the set is ABC. So, if I write, I can write that this element A belongs to. This symbol is actually read as belongs to. So A belongs to, this element A belongs to set A. Similarly, I can write B belongs to, this element B belongs to set A. And C belongs to set A. So what we are going to call this symbol? Belongs, belongs to. I hope it is understood. Right? If you have to represent anything which does not belong to, so I can write it as, let's say, D. Can we see D over here? No. So I will write D. This is belongs to. So to represent does not belongs to, we'll just cancel it like this. So D does not belong to A. Set A. So does not belong to is also pretty much clear. I hope it is clear now. Fine. Now we have different ways to write the set, or you can say different methods to represent the set. We have actually three methods. I'll be telling you all the methods. First is your description method. Second is your, you can say, roster or tabular method. Or roster method. And the third is set builder. With the help of one example, I will try to explain all these methods. So let's take one example. Okay. Description method means here whatever the elements are there in the set, they are just written in a statement, you can say, describing the nature of those elements, or giving some common property, or mentioning some common characteristic of that of those elements of that set. So let's take one example. Let's say I have, let's say this is your set whose name is A. So this method is actually the tabular method or roster method. This method is actually tabular method or roster method. In this particular method, tabular or roster, we write the elements of the set individually and separate them with the help of comma, and write them in the braces, curly braces. For set, if you have to write any of the methods. If you have to write the set in any of the methods, curly braces should be there. Okay, everything to be written in curly braces. So this is your tabular or roster method. Now see how I'm going to write it in descriptive form or method. So I will write it as can you just tell me what are these? These are actually natural numbers which are less than 5. Can you say like this? Yes. So here you can say natural numbers less than 5. That's it. This is your which form? Descriptive form. Nothing else to be mentioned. This is your descriptive form. This is your descriptive form. Let's see the most crucial as per these students, the set builder form or the set builder method. So here you have to be cautious that what nature or what characteristics or what properties you're going to see in that set, and you have to mention those properties, or with the help of those properties you have to mention a statement. So when you don't have this thing and you read that set builder form, you are able to find out all the elements of that set. So I have to write that set in which form? Set builder form. In such a way that when I read that set builder form, I am able to tell all the elements of the set. So here I can now since these are the elements, so I'll just take a variable which is going to tell that this variable denotes the element of the set. So let that variable be x. X will be 1, x can be 2, x can be 3, x can be 4 as well. Okay. So here it is a variable whose value is changing according to the element. So I'll write it is the format to write first x such that these column we'll read it as such that we have one more way to represent it. This line you can draw. This is also will be read as such that. So x such that x belongs to natural number. What I've done here, I've just written that x belongs to natural number. So from here we came to know that whatever elements are present in the set, they are natural numbers. Same thing you have to write here also. In these two sets, nothing is different except this such that. Rest everything will be same. So x such that we'll read it as x such that x belongs to natural number. And now natural number are in infinite. They are an infinite number. So here I have to mention some particular numbers. For that you have to write that from which number to which number the elements are there. So I can write it as x is greater than equal to 1 and less than equal to 4. This way also you can write. So here if I read this, so this is your set builder form, it is complete. Why? First I have written what is the nature of the elements and from where to where the elements are present. So this is a set builder form. Now assume that you don't have this. Now you have to write the set builder form in roster form. So you will read the set builder form. So now we'll read it x such that x belongs to natural number. From this statement we came to know that yes, whatever elements are present in this set, they are natural numbers. Fine. Now the natural number starts from 1. Okay. Now here from 1 to where? Till what number I have to write in that set? So that will be given by this condition. So he is saying x is greater than equal to 1. So it means it is starting from 1. And x is less than equal to 4. It means it will go to 4. the x equals to 1, 2, 3, 4. So the elements of this set will be what? 1, 2, 3, 4. We can write the other way also. See, I can write this also. X is greater than 0 and x is smaller than 5. This also I can write, right? Because x is greater than 0, so after 0 what comes? 1 as a natural number. So 1 will be the element in that set. We'll go to 2, then 3, then 4. Now, he's saying x is less than 5. So what is less than 5? The natural number. 4 is the natural number which is less than 5. So it will go from 1 to 4. This way also you can write. So you have to keep in mind that what you want to put. You want to put less than equal to sign or only less than sign. That depends. So you have to be very careful while putting these signs. Okay. So this is your cell builder. So this is a description or you can say descriptive form or method in which you have to just write a statement which is going to tell everything for that particular set. In tabular or roster form, you have to write the individual elements or individual members and they will be separated by comma. And in set builder form, this is the format that you need to keep in mind. Where we are going to write x is that x. Now after that, it depends on the elements of the set what we are going to represent. So here in this set, we are representing all the natural numbers. So therefore, x says that x belongs to natural number. From here, we got the nature of the elements. Now, from where to where the elements are present, so that will be given by the boundary of that x. From which element to which element it is going. From which number to which number the numbers are present in the set. So x is greater than 0, so it means 1, it will start from 1. And x is less than 5, so it will start from 1, 2, and it will go up to 4 because it is less than 5. Or you can write x greater than equal to 1, so equal to is coming, so we will write 1 also, then 2, 3, and now he's saying x is less than equal to 4, equal to is coming, so we will include 4 also. So this is the way to write this. I hope it is clear. So we'll finish it off here, and next concept I'm going to give it in the next video. Thank you so much for listening to me. If you have enjoyed it, please do like it, and thank you.